we're going to start by being more familiar with exponents. So there are two pieces to an exponent. It's also known as a power. So I'm going to use the example of 5 to the power of 4. So this bigger number here, this is the base. This smaller number is the exponent. And altogether, it's a power. But let's break apart these pieces and become more familiar with what they mean. So a common mistake is to think that 5 to the power of 4 is just 5 times 4. And that's not correct. If it was just 5 times 4, we wouldn't have this special way of writing it. We would just say 5 times 4. Instead, an exponent is when the base, or the bigger number, is being multiplied by itself however many times the exponent indicates. So in this case, our base is 5, and so that's the number that's being multiplied, and the exponent is 4, and that's why it's being multiplied 4 times. So this is actually an expression, and we can either solve from left to right, or since the only operation is multiplication, you can kind of jump around. I like to go from left to right just to make sure I don't forget any, especially when we end up with exponents that have a large number. We could be multiplying a lot of different numbers together, and so it's easier to go from left to right, so that way you don't forget any. So starting on the left, 5 times 5, that's 25. Bringing down the rest of the 5s. Again, to the left, 25 times 5, that's 125. Bringing down that last 5. And then 125 times 5 is 625. It's supposed to be a 5. That's awful. You got it. It's a 5. So that means that 5 to the power of 4 is not 20. It is not 5 times 4. It's actually 625. Now let's do another example, but this time we're going to deal with negative numbers. So let's say I have negative 3 to the power of 5. So negative 3, that's the base, and 5 is our exponent. So we can write it out in expanded form. Negative 3 times negative 3 times negative 3 times negative 3 times negative 3. So I have negative 3 being multiplied 5 times. Starting from the left, I'm going to go negative 3 times negative 3. Now we need to remember our negative property. When I am multiplying two negative numbers, the answer is positive. So negative 3 times negative 3 is positive 9. And now I'm going to bring down the rest of the 3's and continue from the left. So now we have a positive 9 times a negative 3. Well, a positive times a negative is a negative. So 9 times 3 would be 27. So positive 9 times negative 3 is negative 27. And again, bringing down the rest of the 3's. Still from the left, negative 27 times negative 3. So a negative times a negative is going to be a positive. 27 times 3 is 81. And then bringing down that final times negative 3. Now that we have a positive times a negative, I know my answer will be negative, and 81 times 3 is 243. So negative 3 to the power of 5 is negative 243. Now there is a pattern here. Since multiplying negatives create a positive, if the base is negative, when the exponent is an odd number, like it is here, 5, our answer will be negative. If the exponent, I'll write it over here, was even, then the answer will be positive. So that's a great way to kind of check at the end. Determine whether the exponent is odd or even. If it is odd, your answer should have been negative. If it's even, your answer should be positive. And this only applies when the base is a negative number. Because if the base is positive, we are not dealing with negatives at all. So now that we are more familiar with exponents, we need to identify the connection between exponents and roots. And exponents and roots are actually opposites of each other. Similar to multiplication and division, right? Those are inverse operations, they undo each other. Addition and subtraction, those are inverse operations, they undo each other. The same thing is true with exponents and roots. They undo each other. So, let's use an example. I'll go ahead and erase this too. So I'm going to do the example. This is called a square root, because there are multiple types of roots. It looks like this. And we're going to find the square root of 25. So this symbol here, this is called a radical. And the number inside the radical is the radicand. Okay, so what does this mean? This is saying what number times itself equals 25. And in this case, the answer is 5. So I can write that the square root of 25 is 5, because 5 times itself is 25. But there is actually another answer. Remember our properties of negative. A negative number being multiplied by a negative number is positive. So negative 5 times negative 5 is also 25, which means that because I am multiplying the same number by itself, negative 5 and negative 5, negative 5 is also the square root, or 25 is the square root of 5, and 25 is also the square root of negative 5. So there can be multiple answers. So as I mentioned, there are multiple types of roots. So we're going to start by working with a square root. Square roots look like this. And we were trying to figure out what number times itself gave the answer, right? And it was 5. So the square root of 25 was 5. But we also use something that's called a cubed root. We are still using a radical sign, but now inside the little check at the beginning, you will see a tiny 3. And what that means is that whatever number is inside the radicand, we need to figure out what number multiplied by itself 3 times gives us the number inside the radicand. So let's say I'm going to do the cubed root of 64. So I'm trying to figure out what number multiplied by itself 3 times is going to give me 64. And in this case, the answer is 4. So the cubed root of 64 is 4. Now remember I said that negative 5 times itself is also 25, right? So the square root of 25 could be 5 and negative 5. Let's see if that can also happen with cubed root. So if I say negative 4 times negative 4 times negative 4, starting from the left, a negative times a negative is a positive. So 4 times 4 is 16. Bringing down that final times negative 4, well, a positive times a negative is a negative. So 16 times 4 is 64, but our answer is negative, and that is not the radicand. So the negative option that we had with the square root does not work for a cubed root.